reviewing Chapter 9. These are the topics that have been covered. It seems like it's been a while since we have done the first couple of sections, so we need to do a review here. 9.1 is adding and subtracting polynomials. Remember, you have to add or subtract like terms. The big thing here is on subtraction. Make sure you carry the subtract sign through to each term in the polynomial. 9.2 was multiplying polynomials. We had where we just multiply a monomial, which would be the distributive property, multiplying two binomials, which is FOIL, and then multiplying a binomial times a trinomial or polynomial with more than three terms. We call it vertical or horizontal multiplication. And then multiplying special products, which was the sum and difference or squaring a binomial. The last 5 sections are all of the sections about factoring. And then obviously we learn to do that so we can solve a polynomial. So let's look at some problems. Let's start with an addition problem. Let's take 9x plus 6x cubed minus 8x squared, and let's add to that negative 5x cubed plus 6x. Now we're adding, so we just line up the like terms. This would be lined up under the x cubed term. This would be lined up under the x term, and we add the terms together. This is 15x. This would be a 1x cubed, so we don't generally write the 1, and a minus 8x squared. We generally want to put this in the correct order, so this term would come first, the x cubed term, then the x squared term, and then the constant. So x cubed minus 8x squared plus 15x. Make sure you copy it correctly. A subtraction problem. Let's take (3n squared minus 4n plus 1). And let's subtract the polynomial 8n squared minus 4n plus 17. The important thing about the subtraction is to make sure the subtract sign carries through, which what it does is change the sign. This becomes negative 8n squared, just going to line it up here. This becomes positive 4n, line it up there. This becomes negative 17. And then you can just do your adding. Remember, subtracting is adding the opposite, so we basically add these. This is a negative 5n squared. This is 0. Negative 4 and positive 4 is 0 times n, which is 0. And then a minus 16. Multiplication. Again, there's several different kinds of problems. You can have where you just distribute, like x times x squared plus 3x plus 5. You just distribute x cubed, this is your multiplying, plus 3x squared plus 5x. That's a single term times, or a monomial times a binomial or trinomial. Let's take 2n plus 3 times n minus 4. When you have two binomials, this is FOIL. Your first terms, 2n squared. Your outers, minus 8n. Your inners, plus 3n. Your last, minus 12. Typically, the middle terms will join together as like terms. That would be a minus 5n minus 12. That would be your answer. Then if you have n plus 2 times n squared plus 5n minus 4, You can multiply n times everything, distributing it, then 2 times everything. Line it all up horizontally. I prefer the vertical method just because I can line my terms up right here. I don't care which way you show it when you do a quiz or a test for me. Multiply everything by n. So that's n cubed plus 5n squared minus 4n. Then grab a different color here. Multiply everything by 2. 2n squared, that would line up here. 10n, that would line up with that one. And minus 8. Then we add that all up, and it should be in the nice order for us. N cubed plus 7n squared, that would be a 6n, and a minus 8. There is your final answer. Always go back and double check what you've multiplied. Remember, we frequently say we're all human, we make mistakes. N cubed, 5n squared, minus 4n. 2n squared, 10n, negative 8, and then double check your addition. Remember, most math problems, you can check it before you actually turn it in for a grade. So that is pretty much the multiplication. Then we did have some special products. Remember the sum and difference? Like x plus 2 times x minus 2. Now you can always do it by FOIL. The middle terms are going to cancel each other out, the outers and inners. That's why we learn the special product. You basically just square the first minus the square of the second one. Because if you do the FOIL, you'll get minus 2x plus 2x, so they cancel each other out. X minus 10, x plus 10. It's the square of the first thing minus the square of the second thing. That was your special products. That was section 9.3. The other one in 9.3 is the square. We'll do a plus and a minus, x minus 5 squared. Remember, you could set this up and do it by FOIL, but it's basically square twice product square. This is a little shorthand way to do it. So you square the first thing, that's x squared, multiply them and double it. 11x becomes 22x, and then the square of the last one. That's what you would get. X plus 11 and x plus 11. If you decided to do it by FOIL, you have x squared, outers are 11x, inners are 11x, last is 121, and that's where your middle term is twice the product. You have the x minus 5. It's the square of the first thing. Middle term will be minus, because that's negative 5x, double it, negative 10x, and negative 5, and negative 5 is plus 25. And that's how you get it. Square the first thing, double the product, minus 5x becomes minus 10x and plus 25. So that's a quick review of what was in 9.3, the special products. You can always multiply by FOIL. If you have, let's do 3n plus 5 squared. Remember, this is the square twice product square. So you square that, you get 9n squared. The product is 15n. We got to double it for 30n, and the square of the last thing is 25. Again, if you write that twice, that's what 3n plus 5 squared means. 9n squared plus 15n plus 15n, that's where you get the 30n. And then your last is plus 25. Factoring, again, on each of these problems, you should be pausing the video and see if you could work it on your own. I'll just do a few examples, and I would recommend that you go through the chapter review. I think your answers are in the back of the book, or go through the sections in the book, practicing some of the odd problems. Factor. Let's try n squared plus 15n plus 26. Now we know this would be an n plus and an n plus, because the end is 26 positive and the middle is positive, so they're both going to be plus. I would need factors of 26 that give me a sum of 15. So let's see, right offhand, I don't know what it is, but I'm going to figure it out, and that looks like it. So it's n plus 2, n plus 13. Let's check it, make sure I'm correct. N squared. The outers are 13n, inners are 2n. That gives you 15 and plus 26, so it should be correct. Looking for some different problems for us to try. Again, pause the video and factor it. Again, this is going to be a plus and a plus because it's positive 15. I need a sum of 8. 1 and 15, 3 and 5 are my factors, and that looks like the one that's going to work. And always double check this. Again, many people work these. They'll put down an answer, turn it in, and it's wrong, and they never check it. Let's just say that somebody said, well, I'm going to do 1 and 15. I have people turn this in for the answer, but let's check it first. Outers, inners, last. That's 16C. That is not what's in the middle, so you know that you need to try again. Let's take x squared plus 4x minus 32. Again, pause the video and work it out. I know there's going to be one of each because it's a negative 32. I could use 1 and negative 32, negative 1 and 32. 2 and 16. See, that one negative, that one negative. None of those have 4 yet. Let's see, 3 is not a factor. 4 is, what's that, 4 and 8? Negative 8, positive 8 with the negative 4. That gives me a sum of 4. So it looks like x plus 8, x minus 4. Again, I need to double check it, make sure I didn't go too fast and put down the wrong thing. The first are x squared. I'll put my check over here. The outers are negative 4x. The inners are 8x, and the last is negative 32. So when I check that, I get plus 4x minus 32. And I do have the right answer, and that's what you should be checking. Factoring, when let's try this problem. X plus 3, I'm going to go ahead and write it like this, except that's a minus 7n equals 0. Let's subtract. First of all, I need to write this correctly in order. And remember, this is the one that you could sit here and figure out trial and error. I know it's a minus and minus, and I know this only breaks 3 and 1, but the problem is this could be 4n and 1n or 2n and 2n. So if we use our, remember we multiply the a and c, which is a positive 12, and then we looked to find some factors of 12, that would give me that 7. I'm going to want the negative one, so I have negative 1, negative 12, negative 3, negative 4. It looks like that's what I want to write. So I would get 4n squared. I'm going to put the minus 4n minus 3n plus 3 equals 0. Actually, this one said equal, so we're going to solve it. Factor and solve, but if you just factor, it's factored. If you solve, then you have to set each thing equal to 0. Slide this up. When you group these, you need to be very careful. These would group together, but you need a plus so that that negative sign gets carried with the 3. So let's see, we are going to factor out, they look like they have a 4 and an n, so that leaves me an n minus 1 plus, write that sign in there. I'm going to factor out a negative 3 so that it leaves me the n and then plus negative 1. That gives me a positive 3 because I want the same thing that's here, equals 0. And again, that's the same as n minus 1. So they have a common factor of n minus 1. When you take that out, you have 4n minus 3 equals 0, because we're actually solving. Now, when you're solving, we set each part equal to 0. We add 1, we get n equals 1. We add 3, divide by 4. There are your two answers. Now, you can go back and substitute those in and check them. The check's a little bit harder, but you can do it just to make sure that your answers would be correct. So that is solving when the leading coefficient is not 1 or the x term is not 1. And again, that's multiplying that a and c term and then dividing that up so that the middle term then can be factored by groupings, pairing it up to factor. Factoring special products or solving. If you have this problem, minus x squared, you recognize that those don't have a GCF, but that's a perfect square. 10x, perfect square is y. It's 10x plus y times 10x minus y. That's factoring what's called the difference of squares. Let's find a problem, couple problems to solve. And it's by factoring. $25a equals 10a squared. Now remember, we need to set this thing equal to 0, and because that's my leading term and I like to keep it positive, I'm going to move the 25a over to this side. Get 0 equals 10a squared minus 25a. Now there's always look for a GCF, which this one has one of 5a, and that leaves me 2a minus 5. Is that correct? Let's check it. 10a squared minus 25a. Another piece of paper here. So remember, I have it factored. Either of these factors can be 0. Now, some people will just say 5 can't be 0, so a equals 0. Or some people will say 5a equals 0. It doesn't matter which way. A equals 0. 2a minus 5 equals 0. So add 5, divide by 2, and then your answers are a equals 0, or 5 halves, or you can say 2 1/2. Really wouldn't matter how you write that, 0 or 5 halves. Most of them, I think your book is going to leave it as 5 halves. Let's take n cubed minus 121n equals 0. And let's solve. Remember, if it's equal to 0, don't forget to carry that through each time. Don't leave off steps. There is a GCF of n. n cubed minus 121 equals 0. Hopefully you recognize when you only have two terms, it's generally going to be a difference of squares, n plus 11 and n minus 11 equals 0. Set each factor equal to 0. N equals 0. N plus 11 equals 0. N minus 11 equals 0. Subtract 11. N equals a negative 11. Add 11. n equals 11. There's your answers. You can write n equals 0, negative 11, positive 11. Some books will say 0, plus or minus 11. You can write it any of those ways. You should review Chapter 9, and we will be setting up for a test in the next few days.